Hey guys, 5.3 day 2 today, and I have a goal. I'm going to try to get this right the first time through. Seems like the last several lessons I've had to record at least twice, so my goal is to get it the first time down. So wish me luck, okay? The difference between 5.3 day 1 and 5.3 day 2 is in 5.3 day 1, they were asking you to find the solutions that were on the unit circle, okay? Or in this interval, which is the same thing as saying on the unit circle. So they were saying, okay, where are the answers here that solve the equation that you have? Okay, where today they're going to say, we want all the solutions, not just on the unit circle, but anywhere. Okay, so if you think about it, let's say that our answer was 0. Okay, we came up with the cosine of x is equal to 1. If we came up with a cosine of x is equal to 1, that's this point right here, which is 0. So that means that this is true at 0, but it's also true at 2 pi and 4 pi and 6 pi and 8 pi and so on and so on. Okay, it's also true at negative 2 pi and negative 4 pi and negative 6 pi and so on. Okay, so our answers are going to have to be written a little bit differently because each problem is going to have an infinite number of solutions. Okay, so let's go through. What I've decided to do is to start with the same first example that we started with the other day, only the directions are going to be different. So instead of saying find the solutions in this interval, they're going to say find all solutions. Okay, and there are going to be an infinite number of solutions. Okay, but there's going to be a shortcut for how to write it. Believe me, we don't have to write them all out and then, or write out several of them and put ... There's a way to do this. Okay, so first of all, to solve this, again, we can still move things from one side of the equation to the other. So I'm going to add the 1 over to the other side. I'm going to divide both sides by 2. So this is the exact same problem that we started with on day 1. And we went to the unit circle to find out when this was true. So when was the sine of x equal to 1/2? Well, it was here at pi over 6, and it was also here at 5 pi over 6. Okay, so pi over 6 and 5 pi over 6. Okay, but those aren't my only two answers anymore. Pi over 6 works, but if I go around the circle one more time, which would be what, 13 pi over 6, that works too. Okay, and continuing to go around the circle one more time, all these coterminal angles, if you remember that word, are all going to be solutions. So the way that we write that is we write plus 2 pi n or plus 2n pi. You see it both ways. Okay, and it doesn't really matter, but you're going to tack this on the end of your answer. So this said we could add 2 pi times 1. We could add 2 pi times 2, 2 pi times 3, 2 pi times 100, 2 pi times negative 12. Okay, any multiple of 2 pi plus pi over 6 is going to be our answer. Okay, and the same thing with 5 pi over 6. Okay, so we're in day 1, we stopped here. In day 2, we list these as our answers. And again, this plus 2 pi n could be 2n pi, doesn't matter, okay? Doesn't matter. All right, I hope that makes sense to you, okay? Because all of those angles have a sine equal to 1/2, okay? And from there on, it's basically the same thing we did the other day, but you do have to be careful when we get down to these examples where we switch to tangents and cotangents because those are a little bit different, okay? So we're gonna stick with these for now, okay? And let's take a look at this one right here. Okay, I'm gonna add my sine of x over to this side. So I'm gonna get 2 sine of x over here. I'm gonna subtract the square root of 2 over here, okay? And then I'm gonna divide both sides by 2. So the sine of x is equal to the negative square root of 2 over 2. Okay, and I'm going to go to my unit circle and see when that's true. Okay, so sine again is my second, my y value. So negative square root of 2 over 2, these are all positive. Oh, there I am. There's one of my answers. 5 pi over 4 Okay, but I'm not going to just write that. I'm going to say plus 2 pi n, okay, because it could be this answer or this answer or this answer, okay? And then my other negative square root of 2 over 2 is right here at 7 pi over 4. Seems pretty straightforward, doesn't it? Okay, now we're going to get a little trickier. Okay, we're going to get a little trickier. With this one, I have a tangent, and that's going to be a little bit different. And if you're thinking about why, by the way, I forgot to write this on all of these. They're all going to be asking today for all solutions. Okay, and then on Thursday's assignment, we're going to mix together some problems that are only in the unit circle and some that are all solutions. Okay, so for these, we're all going to be all solutions. Okay, why is this going to be different? Well, let's wait till we solve it and then I'll show you that. Okay, I want to get tangent squared by itself, so I'm going to add the 1 to both sides. Oops, I forgot my x. And I'm going to divide by 3. And I'm going to square root both sides of my equation. And when I square root, I'm going to get a plus or minus. Okay, so I have plus or minus. Square root of 1 is 1 over the square root of 3. Okay, we could write it the square root of 3 over 3, rationalize, but there's really no point in doing that because when we go to our unit circle, that's not really going to be helpful. Okay, so it's probably better if we just leave it like this. Okay, so if I go to my unit circle, when is the tangent, remember tangent is the y divided by the x, going to be plus or minus 1 over the square root of 3? Well, here's one possible answer right here, pi over 6. Okay, I'm going to continue to go around my unit circle and see if there are any others. Here is another one at 5 pi over 6. Okay, but I want you to remember that the period is different for tangent and cotangent. The period is different. Things don't repeat every 2 pi. For tangent and cotangent, they repeat every pi. The period is pi. Okay, so that means when I get pi over 6 to have this answer, if I go straight across the circle at 7 pi over 6, that means I'm adding pi. This is also going to have the same tangent. And if I take the answer 5 pi over 6 and I go straight across the circle to 11 pi over 6, this is still going to have a tangent of negative 1 over the square root of 3. Okay, so instead of writing all 4 answers that are on the unit circle plus 2 pi, we're just going to say plus 1 pi n. So instead of having to list 4 numbers plus 2 pi n, I'm only going to list 2 numbers plus pi n. Okay, and this is going to happen whenever you have a tangent or a cotangent. And in fact, I'll show you later, sometimes it can happen even if you have a sine or a cosine or something that has a period of 2 pi. Okay, that's a little bit tricky, and that's one of the things that usually confuses people is when do I use 2 pi n, when do I use pi n? In general, when you have anything except for a tangent or cotangent, you're going to use 2 pi n. Okay, when you have a tangent, you're going to use pi n. Okay, and I'm going to show you that when we get to our very last example. I think that'll be clearer. Okay, all right, let's go to this next one. Okay, I'm going to get everything on one side here because I think this is a factorable problem. I think I could do GCF factoring and take out a cotangent. And I'm left with cosine minus 2. Okay, I'm going to set each of these equal to 0. Set this equal to 0, and I'm going to set this parenthesis equal to 0. So if the cotangent is equal to 0, now you may be fine going to the unit circle and finding the cotangent. Personally, I always have a hard time wrapping my brain around that. I much prefer to look at the actual function rather than the reciprocal function. If the cotangent is 0, the reciprocal of that, this is 0 over 1, is 1 over 0, which means the tangent is undefined. And we want to know when the tangent is undefined. Okay, so remember, it's y divided by x, so this would be 0. This would be undefined. This would be 0. This would be undefined. But I don't have to write both of these. I only have to write pi over 2 plus n pi. Okay, and I'm only halfway done. I still have to solve this one, but there's that first half of my answer. Okay, now I want to solve this one. Cosine squared of x minus 2 equals 0. The cosine of x squared is equal to 2. And if I square root that, I get the cosine of x equals plus or minus the square root of 2. And when is that true? Never. Absolutely never. So this half of it is a no solution. So the part that I boxed already is my only answer. Often these both have answers, okay? But sometimes one of them will be a no solution. Very unusual if you would get both of them to be a no solution, okay? But if you did, then the overall answer would just be a no solution. Okay, now here's that last example that I promised you, okay? This is going to get a little bit messy, okay, because it's a sine, but it's going to be a little interesting here. I'm going to solve this. I'm going to add the 1 to both sides. I'm going to divide both sides by 4. And I'm going to square root both sides of the equation. And when that happens, I get the sine of x equals plus or minus, you always have to plus or minus when we square root both sides, 1/2. If I square root 1, I get 1. If I square root 4, I get 2. Okay, now this has a lot of answers, okay? Where is the sine equal to 1/2? Well, here's 1, pi over 6. Here's another 5 pi over 6. Here's another at 7 pi over 6. And here's another at 11 pi over 6. Because of that plus or minus, instead of getting my usual 2 answers, I'm going to get 4 answers. So I could write my solution out, pi over 6 plus 2n pi. 5 pi over 6 plus 2n pi, or 2 pi n. 7 pi over 6 plus 2 pi n, or 2n pi, and 11 pi over 6 plus 2n pi. So this is one possible way to write your solution. It's really not the preferred way. It's not the way your book is going to do it, because your book is going to say, wait a minute, we don't have to write all that out. Even though this is a sine, because I had that plus or minus in there, I can wipe these two out, both of these, by saying pi over 6 plus n pi. And I don't have to say both of those, because if I add n pi, I automatically get, these two, pi over 6 and 7 pi over 6. And then if I combine these two together, I can just say 5 pi over 6 plus n pi. And so this is the way that the book is going to write your answer, and this is really the way the preferred answer is going to be. And there could be some teachers that would take a point off if you did this instead of this. I'm not one of them, but I know that some teachers do. Okay, so you can see that even though it was a sine function and you'd think you would have a plus 2n pi instead of a plus n pi, because of the plus or minus, we can more easily write it with the n pi. Okay, I hope that made sense. I hope to see you all at the Zoom meeting, and I hope you all have a good day. Talk to you soon. Bye.